Hello everyone, and this is Devabrata here. So welcome you to our channel Schrodinger's Cat. And in our previous lecture, we have discussed the topics kinematics from class 11, and today another important topic, that basically the current electricity. Today we will discuss. So first of all, one thing is that for your exam point of view, today we just discuss the chapter summary in a nutshell, and after covering all the topics we just do a theory elaborately, and total 10 problems coming in NEET JEE Main and Advanced. So let's get started. Basically today first one is the electric current, drift velocity and mobility. Second one, Ohm's law, resistance and resistivity, combination of resistors, cells, its combination, and Kirchhoff's law. Formally the electrical energy, heating effect of current and electrical power. Last one is measuring instruments. So in your NEET exam, basically for the NEET UG, in the current electricity chapter there are 2 or 3 questions are coming, and for JEE Main 3 or 4, and the JEE Advanced the 3. So this is another important topic. So first one we just discuss here, that the current electricity, so electric current and the circuit. So basically for this we just draw a line here for your clear visibility of my writing. So first of all, that the current, basically the electric current I is defined by Q by T, and this is the dq dt, and some notation is that N be the number of electron per unit volume, A be the cross sectional area, L be the length of conductor, E be the electric field strength, V be the potential difference, sigma conductivity, E and M charge and mass of electron, 1 by R basically the G conductance, T naught be the relaxation time, R be the resistance, rho be the resistivity, and Vd is the drift speed but drift velocity. So basically second one is the current density, is defined as the J cap. The current density is I by A, current per unit area, is written at NEVD, where Vd be the drift velocity. So the current would become that NEAVD, current become NEAVD according to the drift speed. Second one is the Ohm's law, basically the V equal to IR, written as del V is equal to I del R. This is the scalar form, simply written as V equal to IR basically, and in vector format that J equal to sigma E. This is the Ohm's law in vector form. Resistance of a conductor of cross sectional area A and length L, the resistance would become R equal to rho L by A. Relationship between the sigma and the rho, sigma is equal to 1 by rho. For metallic conductor the sigma is N square T naught be the relaxation time by 2m. Effect of temperature on resistivity and resistance. So basically the RT is equal to RT naught 1 plus alpha T minus T naught, and the rho T would become rho T naught as usual 1 plus alpha T minus T naught, where the alpha be the coefficient of resistivity. So go ahead, our next topic is that combination of resistances, basically for the series combinations. So this is the R1, R2, R3, R1, R2, R3, so I will be the fixed for series. Here the R series is equal to R1 plus R2 plus dot dot, and here the voltage V would become that V1 plus V2 plus dot dot. In parallel format, that this is the R1, R2, R3, and the current going through it become I. So R1, R2 and the R3, here the I1, I2 and the I3, I1, I2, I3, here would be the I. So basically here V would become same. So 1 by R parallel Rp is equal to 1 by R1 plus 1 by R2 plus dot dot. And here the current I would become I1 plus I2 plus dot dot. Next one, current in resistors joined in parallel. This is important for your exam purpose, basically the JEE. So this one, the resistance here. So so another one is that this one. So this is connect in this form. Suppose this was R1, R2, here the current I1, here I2, this is total current I, this is plus to minus, and this is I. So in this form, I proportional to 1 by R, simply written as that I by I1 is equal to R1 by R2. This is basically the junction format or joint format, and I1 would become total current I, resistance of R2 by total resistance R1 plus R2, and the I2 would become total current I, resistance of R1, R1 plus R2. So next one, with the combination of cells, combinations of cells. So if n cells whose internal resistance is R is connected in a series with EMF E and external resistance capital R, then the current would become in this form NE NR plus R. If NR less than capital R, then the I would become NE by R. This is in the series case, and for the parallel case, the current would become E by R by N plus capital R, and if R is negligible, basically R tends to 0, negligible means, so I would become NE by R. This is the cell in the series and parallel combinations. Go ahead our second topics. So formally, this is the heating effect of current. Heating effect of current. So work done, W equal to VQ. Q means the charge. Heat dispatched in conducting air is defined as the heat W is equal to VIT is equal to I square RT is equal to V square T by R in joule. Heat generated H equal to W by J. Here J is 4.2 joule per calorie. And in CGS format it would become A is equal to W by 4.2 is equal to I square RT divided by 4.2 is equal to VIT divided by 4.2 is equal to V square T by R, means 4.2 R. This is in CGS. Calorie is written CALORIE. Another one, C means Coulomb. So third one is the electric power is defined as P W by T watt. This is equal to Q into V by T. P equal to VI is equal to V square by R is equal to I square R in watt. Second one is the Faraday's law of electrolysis. So Faraday's law of electrolysis states that the amount of substance deposited or dissolved on an electrode is proportional to the quantity of electricity passed through the electrolyte is defined as the M is proportional to Q, or M proportional to IT, or M equal to ZIT. Proportionality constant is coming over constant ZIT. Second law is defined as the amount of different substances deposit on electrodes by the passing same quantity of electricity through different electrolytes are proportional to their equivalent weights. You just go through in your chemistry electrolytes chapter. This is written as the M proportional to capital E. Using first law proportional to M EQ, or M equal to 1 by K EQ. Also the final outcome M1 by M2 is equal to E1 by E2. K is a universal constant. Here the K value is equal to 9.64 into 10 to the power 7 Coulomb per kg. Next one is the relationship between the electromotive force and terminal potential difference of a cell. So basically for doing this, suppose this is a internal resistance here, and here is this one is K key and the external resistance. Here is a ammeter. This is K, R, this is R, and here this is E, and the total current is I. So written as V equal to E minus IR. Here R means internal resistance. When battery is giving current, if current is supplied from some other source to cell, written as V equal to E plus IR. So next one is the Kirchhoff law. First law, Kirchhoff law, first one is for junction or current law. Current law or junction law. Suppose P junction and the current this this is P, current coming I1, pass I2, I3, I4, incoming I5. So it's saying that in any circuit at any junction sum over I is equal to 0. So I1 incoming, I5 incoming, I2 outgoing, I3 outgoing, I4 outgoing equal to 0. So I1 plus I5 is equal to I2 plus I3 plus I4. Go ahead our third topic. Basically, so second law is the loop law. Loop law, suppose this is a resistance, another one, this one, another one, this one. This is a point A, B. Here this is E1, E2, R1, R2, R3. Here current I1, I2 and total current I1 plus I2. This is the loop 1, loop 2. This is current I2. Here current is these directions. Is saying that in a closed path of any electrical circuit, sum over IR, current into resistance, is equal to sum over E, EMF. So in loop 1, you just say that the I1 R1 minus I2 R2 is equal to E1 minus E2. In loop 2, that I2 R2 minus total current I1 plus I2 R3 resistance equal to E3. This is the loop law. Sorry, E2. Here is nothing, E3, so it would become E2. Next one is the Wheatstone bridge. Basically, in balanced bridge ratio of resistance in adjacent arm are equal to the ratio of the other two arm resistance, imply that P by Q is equal to R by S. I just not draw here the figure. Basically, Wheatstone bridge is in the format of this one HP, this one Q, this one R, this one S. Here this is a galvanometer jointing this one P, Q, R, S, and external here the battery, the cell jointing the E here. So basically here the current I1, I2, here I2, here I1. So potential difference between B and D will be 0. This is the A, B, C and the D. Potential difference between the B and D would be 0. Next one, color coding of carbon resistors. So color coding means for the color black, brown, red, orange, yellow, green, blue, violet, grey, white. Figure 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the color tolerance for gold 5%. tolerance 5%. For the silver 10%, and the no color 20%. So first color, suppose this is a resistance here, resistor, this one. So here 1 2 3 4. First one is define first significant digit, first digit. Second one, second digit. Third one is the multiplier. Fourth one is the tolerance. Next one, the ammeter. So for the ammeter, so basically ammeter is a device to measure electrical current. In ammeter, a resistance shunt having a cell resistance is connected in parallel with a coil. So in the figure, so this is an ammeter and a resistance here in parallel, this one. So here the current going I0, and this is the current I1, this is the current I2, this is resistance, basically the shunt, and this is the ammeter, R0 coil resistance. This is the resistance of R0 coil. So from the Kirchhoff loop law, I1 R0 is equal to I2R is equal to current I0 minus I1 into R. So R equivalent of ammeter is equal to R0 R divided by R0 plus R. So deflection is proportional to current in coil, or deflection is proportional to I1. Deflection of ammeter is proportional to the current. Next one, basically the voltmeter. So voltmeter is a device to measure a potential difference. As usual, let us define. So this is a resistance, and here the another voltmeter with a resistance. Always keep in mind, this is A point and the B. Here the current I0, this is a resistance coil R0, this is R, high resistance, this is the R0 resistance of coil. So plus to minus, this is a voltmeter setup, and the potential difference is VB minus VA is equal to V. So current in the coil I0 is equal to del V by R. So V by R means I0 resistance of coil plus R, high resistance. So R equivalent voltmeter is equal to R0 plus R. So deflection is proportional to the current I0 and hence to V. So here deflection is proportional to current is hence V. Next one, test wire potentiometer. Potentiometer. So this is, I just draw here the figure for the potentiometer. This is a resistance, and here this one is coming plus to minus, this is key, this is another resistance, this is 1 meter, this one, this is here. So this setup, So this is R and S. This point is from the P through galvanometer. This is point C and this point length is L and capital L is the potentiometer state wire length, capital L. This is the epsilon of EMF. Current through is I. So from this figure, this is the standard cell. So here if xy, the distance is capital L and the xp is small l and the V potential of y minus potential of x is equal to V naught. So potential difference between the points x and p is defined as the V is equal to V naught L by L, small l by capital L. So let potentiometer is balanced when xp is equal to L naught and the potential difference between the R and the S is equal to V L by L naught into EMF. This is the potential difference. So process of finding V naught is called the calibration of potentiometer. So calibration of potentiometer is defined as the process of finding V naught. So V naught finding is defined the calibration of the potentiometer. Next one, the arrangement for comparing EMF of two battery. So this is, I just draw here the setup for a better understanding. So first one is this EMF and this is the battery 2. Just a minute. Battery 1 and the battery 2. So after here this joint is galvanometer and this is one length with a battery and a resistance. This is coming in here. This is the battery 1, S1, S2 galvanometer. This point is P1, P2 and the A, B. This is epsilon 1 and the epsilon 2. So P1 is a point at which no deflection in galvanometer for battery 1. P1 is point no deflection and P2 is a point no deflection of battery 2. This is for battery 2 P2 and P1 for battery 1. So AP1 is L1 and the P2 L2. So AP1, this is the L1 and this is the L2 and AB is L unit length and the potential difference VB minus VA is equal to V naught. So then this relation is very important, that epsilon 1 is L1 by capital L into V naught, epsilon 2 L2 by capital L into V naught, and epsilon 1 by epsilon 2 ratio is equal to L1 by L2. This is final outcome, very important for your NEET exam. Epsilon 1 is to epsilon 2 equal to L1 by L2. Basically the epsilon EMF is proportional to the length of the stage wire potentiometer. We just discussed here the chapters nutshell in summary format. Let us assume to go through the problem discussion session. First one is coming in NEET 2024 saying that in the following circuit the equivalent capacitance between the terminal A and B is what? NEET 2024. So you just see here the circuit is assuming is equal to that the P by Q is equal to R by S. Given combination of circuit represent the Wheatstone bridge. Thus this capacitance or the capacitor can be removed. Basically the equal conditions, equilibrium. So this can be removed. So our final circuit would become, so these two in parallel, this can be removed, and this is the 1 and the 2 here, and this is also 1 and the 2. This is connected in 1, this is point B and the A. So basically here the C capacitance 2 by 2 here, this is 1 microfarad, and the C NEET 1 and 1 is in parallel, so 1 plus 1 is 2, just reverse in the resistance, so 2 microfarad. A would be our correct answers. Next one, coming in JEE Main 2023, the equivalent resistance of the circuit shown below between A and the B point, triangular section. So this is also a combinations of Wheatstone bridge format. We just draw for your better simplicity. This one is 1, 2, 3, and this one is 4, and I connected the another resistance here. This is point A and the B, here another resistance 4 ohm, 4, 4, 4, 4, 16 ohm. So this is a Wheatstone bridge format. This section, basically the P by Q is equal to R by S. This is balanced Wheatstone bridge. So simplify the circuit in this form, that this one is 1 and the another resistance. So this one is 1 and this one is another, and here is the another resistance, the 16s. This is the point A and the B. This is 4, 4, 4, 4 and the 16. So you just see here that this 2, 4 is in the series. This is in the series. This is in the series, and these 2 and this are in parallel. So 2, 8 and 1, 16 in parallel. I just write here 2, 8 ohm and 1, 16 is in parallel. So 1 by R equivalent is equal to 1 by 8 plus 1 by 8 plus 1 by 16. So 5 by 16. So equivalent resistance is 16 by 5 is equal to 3.2 ohm. B would be our correct answers. Go ahead. Third one, coming in JEE Advanced 2015, saying that in aluminium bar of square cross section, a square hole is filled with iron as shown in the figure. The electrical resistivity of aluminium and ferrous is given in ohm meter respectively. The electrical resistance between the two phase PQ of the composite bar is. this is a hole, this is a hole, PQ, you have to find the resistance R at PQ hole is what. So these two holes are in hole Fe, resistance, and aluminium L is in parallel. So 1 by R, two resistances here, so 1 by R is equal to 1 by R aluminium plus 1 by R ferrous. So you just R equal to rho L by A, this formula you just apply here. So cross sectional area of aluminium by rho aluminium plus area ferrous rho ferrous L by A. You just put this value. A means outer radius minus inner radius, 7 square minus 2 square divided by rho given 2.7 plus 2 square by 1.0, and this is just transfer in SI unit 10 to the power 6 minus 10 to the power 8 into 1 by, this is the L means given 50 millimeter, so millimeter converted into meter, 50 into 10 to the minus 3. Just calculate and get this result. 1875 divided by 64 into 10 to the power minus 6 ohm is equal to 1875 by 64 micro ohm. So B would be our correct answer, 1875 by 64 micro ohm. JEE advanced type questions. Simply the formula are equal to rho by L, but the question saying is the main concepts. Fourth one coming in NEET 2021. Column 1 gives certain physical terms associated with flow of current through a metallic conductor, and column 2 gives some mathematical relation involving electrical quantities. Match this column. Deep velocity, electrical resistivity, relaxation period, and the current density. All these formulas I just discuss in our chapter summary in a nutshell. So our first theory discussion is very important for your better revision for the competitive exam national level like NEET JEE Main and advanced. So first one is the deep velocity Vd is equal to E capital E by m into tau. Tau be the relaxation time, and the a rho be the m by n square tau. So or tau is equal to m by n square rho, and we just know J equal to current density I by A. So N E A Vd by A is equal to N E Vd, and another J by E by J equal to E. J means Ohm law in vector form sigma E, so 1 by sigma equal to rho, so rho equal to E by J. So first one is the deep velocity A would be 3 E by m tau C. Second one, the electrical resistivity would be E by J. Third one, the relaxation period m by, we just write here m by n square rho, m by n square rho. Fourth one is the current density NEVD. So our final outcome would become A3, B4, C1, D2. This is a matching type questions coming in NEET, so be serious all of the questions. Last one, NEET 2018 is saying that a battery consists of a variable number n of identical cell which internal resistance be the R, which are connected in a series. The terminals of battery are short circuited and the current I measured. Which of the graph shows the correct relationship between the I and the N? We just do these concepts for a chapter summary. That's the series of cells or the cells connected in a series or perpendicular format. So n identical cells are connected in series. So you just write here the E equivalent is equal to NE. Also the n number of internal resistance is connected in the series, so R equivalent equal to NR. So I, you just know del V by R. So del V means NE, R means NR. So this is N. So this is E by R. N would be cancelled. This would be the E by R. So I equal to E by R. I equal to E by R means this is constant. So I is constant. I is constant or independent of N. N be the number of identical cell. I does not depend on N. So basically this would be the does not depends, mean this is the I, the N origin. So C would be our correct answers. We just here discuss the 5 important questions coming in NEET JEE Main Advance, and for your better concept and practice and understanding, I usually give the homework for your better practice and revision. So you just pause this video and take a screenshot of these 5 problems. It's basically the JEE Main and the NEET and advanced types. Just take a screenshot. I just wait 3 or 5 seconds. So I think you just take a screenshot of this problem, you just do in your home and feedback me with this mail ID. Solve this homework, and if anyone needs the file or the study material of the YouTube lecture, just mail without no hesitation. So our famous mail ID catsoddingers1935@gmail.com. Last but not the least is basically the thank you. Stay happy and well. Have a good day.